Good morning, students. I am Elba from the Department of Science. I am going to teach you chemistry for this academic year. I welcome you all to the chemistry online class. Today we are going to discuss about Chapter 8, Periodic Classification of Elements, textbook, page number 106 to 109. First, we can see what are called elements. All the existing matter in our surrounding is made up of the basic unit known as elements. Have you understood? So the matters are made up of what? The basic unit known as elements. Elements are considered as pure substance. What is pure substance? The substance that contain only one kind of atom, molecule or compound are considered as pure substance. Elements contain only one kind of atom. It cannot be broken down. That is, elements cannot be broken down into simpler substance by chemical reactions. Whereas molecules can be broken down into simpler substance, but elements cannot be broken down into simpler substance. Here is an example. Consider the element gold. When you see the structure of gold, it is made up of only one kind of atom, that is gold atom. No other atoms are there. No different kinds of atoms are there. Hence, gold is considered as element. Aluminium is an element. Okay. If you view the structure of aluminium, you can see only the aluminium atom. Okay, wow. So like that, so far we have 118 elements. Among these 118 elements, there are different types of elements. Based on their properties, they are classified or they are divided into metals, non-metals, metalloids. You know what are the properties of metals? They are shiny, isn't it? They are malleable and ductile. They are the good conductors of heat and electricity. Non-metals does not possess these characteristics. They are not hot. They are not malleable except one or two, isn't it? Next one, metalloids. Metalloids show the properties of both metals and non-metals. Now we can see the history of periodic classification. At the beginning of 18th century, we have only 31 elements. See, in the year 1860, the number has increased. Scientists, due to some rapid development in chemistry and due to some advancement in technology, they have discovered 60 elements and they determined their atomic mass. They studied individually all the elements, their physical and chemical properties, and they found that most of the elements possessed similar properties. Hence, they arranged into groups. But later on, due to the discovery of several elements, and that elements have different properties already what they found. See, now we have how many elements? 118 elements. It is very difficult to study individually all the elements, their properties. So, the scientists thought to categorize these elements into groups based on their properties. Have you understood? It is very difficult to study all 118 elements individually, their chemical properties. So they want to categorize these elements because most of the elements had similar properties. So the similar properties in containing elements, they have to put it into one group. Okay, wow. So many scientists made an attempt to classify these elements based on their physical and chemical properties. Let us see that. In 1817, Doppernian, the first scientist, grouped the elements into groups. At that time, only few elements were there and he classified into groups. His classification is called as law of triads. Followed by, in year 1866, John Newland classified the elements into law of octaves. Both classification become failure due to the discovery of noble gas. Noble gas is a non-reactive element, isn't it? So, discovery of noble gas, these two classification come to failure. Okay, these two classification you briefly studied last year in grade 9, chapter 12. For the reference, you can see that. Followed by year 1869, Dmitry Mendeleev. Do you heard this word last year? Yes, in 1869, the Russian scientist, okay, then Russian scientist Dmitry Mendeleev arranged all the elements in order to their increasing order, in order to their atomic mass in increasing order. Okay, he arranged all the elements in the increasing order based on their atomic mass. He thought that the chemical properties of an element is due to the atomic mass. What is atomic mass? Atomic mass means the number of protons and neutrons present in the nucleus of an atom is called as atomic mass. Okay, so he thought that the atomic mass is the basic property which give chemical properties to an element. Okay, so Mendeleev's table totally contains 56 elements and 56 elements are arranged in increasing order of atomic mass. But his table contains lot of discrepancies. What is table? The arrangement of all the 56 elements into what? Columns and rows. Into columns and rows is called as periodic table. He is the first scientist who tabulated a periodic table, who formulated a periodic table. Okay, he is the first scientist who put all the elements in the form of what? Columns and rows. Okay, see, the tables contain so many discrepancies. One is given here. See, let us see. Argon, its atomic mass is 39.95. Potassium, 39.10 atomic mass unit. But argon is placed before potassium. It is wrong, isn't it? Because argon has to come after potassium if it is arranged based on the increasing order. But here argon is placed before the potassium. He did not strictly follow the rule, isn't it? According to him, increasing order of atomic mass. It is not followed here. And second thing, see, potassium, sodium and all highly reactive elements where argon is a non-reactive noble gas. So it is categorized in a same group. Okay, so these are the discrepancies that are found in the Mendeleev's periodic table. Even though Dmitry Mendeleev is called as the father of periodic table, he is the one who put the foundation for the modern periodic table. Okay. Next we can see what is modern periodic table. Modern periodic table in the book, it is given in page number 108. Students, please open the book and view that page. Then only it is easy for you to understand. Modern periodic table was proposed by Henry Moseley in the year 1912. In the year 1912, he overcome the discrepancies of whose? Mendeleev's periodic table, and his table totally contained 118 elements. At the time of his classification, scientists had discovered 118 elements. Mendeleev's table contained only how many elements? 56 elements. And Henry Moseley classified all the 118 elements on the increasing order of atomic number. He chose the basic as atomic number. What is atomic number? The total number of protons or the total number of electrons. This is proton is equal to electrons. So the number of protons or number of electrons that present in an atom is called as what? Atomic number. And he formulated a table called as modern periodic table with 118 elements. This is the table. See, this table contains 118 elements and 80% of the elements are metals and remaining 20% only what? Non-metals and metalloids. The left side portion covers metal, the right corner covers the non-metal, the last column covers the noble gas. Okay, and here all the elements are depicted with their what? See, for example, hydrogen with a symbol. All the elements are depicted with their symbol and their atomic number as well as mass number is given, and which group they belongs to also given here. Have you seen? So this contains 118 elements. Okay, wow. So this periodic table is called as modern periodic table, and he formulated modern periodic law. According to him, physical and chemical properties of the elements are the periodic functions of their atomic number. So from this what you understood, the atomic number is the basic one which gives chemical properties for the elements. Okay. The next one, features of periods. Features of periods. And one more thing, this table contains 4 blocks. See, first 2, group 1 and 2 is called as what block element? S block. Then 13 to 18, group 13 to 18. 13 means from boron to helium. That one. 13 to 18 is called as P block elements. Then group 3 to 12, intermediate elements. Okay, between the first 2 groups and 13 intermediate elements. That is called as D block elements. Down 2 is there, that is F block elements. What is that S, P, D and F means? You know that the main shell and subshells. We have 4 subshells, S, P, D, F. While writing electronic configuration, first 2 columns elements end with subshell S. Similarly, P block elements ends with P, D block elements ends with the subshell D, and F block elements ends with the subshell F. Hence only that S block, P block, D block and F block elements. Have you understood? Now we can see the features of periods. Horizontal rows are called periods. The other name for row is what, ma? Periods. Horizontal rows means just you see from left to right. Okay, left to right. Hydrogen to helium, lithium to neon, sodium to argon, potassium to krypton. So like this, from left to right is called as what? Periods. Similarly, how many periods are there? 7 periods are there. Similarly, how many periods are there? 7 periods. That is from left to right. Okay, wow. First period is called as shortest period with 2 elements. Shortest period with 2 elements. Hydrogen and helium. Second period is called as short period. Third also called as short. First one shortest period. Second and third with 8 elements. Both are also with 8 elements. That is called as short period. Fourth and fifth period is called as long period with 18 elements. How many elements there? 18 elements. Sixth and seventh period is called as longest period with 32 elements. Okay, wow? First shortest, second and third short, fourth and fifth long, sixth and seventh longest. First period contain 2 elements, second period and third period contain 8 elements, fourth and fifth contains 18 elements, and sixth and seventh contain 32 elements. Have you understood? Next, we are going to see about the features of groups. The vertical columns in the periodic table, that is starting from top to bottom. So, periods means from left to right. Am I right? Column means from top to bottom is called as what? Groups. Okay. That is all the 118 elements based on their properties. They are grouped into various families. So, I said 4 block, isn't it? So, S block contain 2 groups. S block contain how many groups? 2 groups. What are they? Group 1 and Group 2. Group 1 and Group 2. Group 1 are called alkali metals. Group 2 are called alkaline earth metals. What is alkali metals? Alkali metals, they react with water and they form basic solutions. The solution that formed by the reaction of first group metal with water is basic. Hence, they are called alkali metals. Group 2 are called alkaline earth metals. The elements present in these groups reacts with oxygen and form oxides. Magnesium oxide, beryllium oxide, isn't it? Magnesium oxide, calcium oxides. Oxides commonly called as earth. And when these oxides dissolved in water, they form basic solution. Hence, they are called alkaline earth metals. Did you understood? So, S block contain two groups, 1 and 2. One group, the name of that family is called as alkali metal. Group 2 is alkaline earth metal. Okay, wow. The next one is D block elements. The next one is what block elements? D block elements. From 3 to 12, the elements from 3 to 12, they are the middle portion you can see. Okay, from 3 to 12 is called as transition metals. They are very hot metals with high density. That is group 3 to 12 are called as transition metals. They are the intermediate metals between S block and which block? D block. They are the intermediate metals between S block and D block, followed by P block elements. Isn't it? The right side you see P block elements. It starts from boron. So here each one is considered as one family. For example, 13 is called as boron family, 14 carbon family, 15 nitrogen family, 16 is called as oxygen family, or you can also call it as chalcogen family. Chalcogen means they are ore formers. See, oxygen, sulfur, mostly they form oxides with metals. So they are called as chalcogen family. They are ore formers. Okay, ma'am. The next one, 17, they are called as halogen family. They forms halide, fluorine, chlorine, bromine, iodine, etc. reacts with metals and they form the respective salt formers. Okay, halogens means halides, that is halides. What are they? Fluorine, chlorine, bromine, iodine, etc. reacts with the metals and they form salt. So they are called salt formers. The last one, 18th. Okay. 18th, it is also P block and they have a stable electronic configuration in the outer shell. Isn't it? You know that any atom, if it has 8 electrons in the outer shell, they are said to be stable. Except noble gas remain does not have 8 electrons in the outer shell. Isn't it? So they are stable electronic configuration and they are unreactive elements. They does not undergo chemical reaction. The next one, F block elements. At the down, you can see F block elements, that is lanthanides and actinides. They are called as inner transition metals because these metals actually present inside the transition metals, that is group 3. Just look at the book, group 3 and row 6 and 7. It belongs, lanthanides belongs to the period 6 and actinides belongs to the period 7 and both belongs to group 3. They are taken outside the table and it is called as inner transition elements. If you take these elements inside the table, then this classification will get to collapse. Metals will go along with the non-metal. This correct table you won't get it. So only till these elements are outside the periodic table. Okay. Till now these two categories, lanthanides and actinides, are outside the periodic table and named as inner transition elements. From you see group wise, hydrogen, except hydrogen, first group remaining all are metals, isn't it? Lithium, sodium, potassium, rubidium, cesium, francium. All they have same chemical properties because if you see the valence shell of these atoms, all they have 1 electrons in the outer shell. The valency is 1. Hence, this group contain what? Same chemical properties. Did you understood, students? If you see each group wise, all the elements in that group contain what? Same valence electrons. What is valence shell? The outermost shell of an atom is called as valence shell. And the number of electrons that present in the outer shell is called as valence electrons. First group except hydrogen. Remain you see lithium, the number of electrons in the outer shell is 1. Sodium 1. Potassium 1. Rubidium, cesium, francium. If you see the structure, all the atom has the valence electron 1. Similarly, second group ends with the valence electron 2. And transition metals also has the valence electron 2 except 1 or 2. They have 1, remaining all have what? The valence electron 2. The boron family, 13th group, 13th group, boron. If you see the structure of boron as well as aluminium, gallium, etc., they have outer shell 3 electrons. Similarly, carbon family, they have outer shell 4 electrons. Nitrogen, they all have in that family. What are the elements? All the end has what elements? Similarly, remaining also oxygen, fluorine has oxygen has 6 electrons in the outer shell, fluorine has 7, and last it ends with 8 electrons, that is noble gas, hence the valency is 0. See students, when you see from top to bottom, the chemical properties will be similar, but the physical properties will vary. What are the physical properties? Such as melting point, boiling point, density. Why? See here, hydrogen has 1 electron, whereas lithium has how much electrons? 3 electrons. Whether they both possess same atomic mass, the mass will be different, isn't it? Hence, the melting point also in hydrogen and lithium need more melting and boiling point, and the density also more. See from here, lithium to sodium, lithium has 3 electrons, sodium has 11 electrons. The size of the atoms also will be larger when comparing to lithium. Am I right? The size goes on increasing from top to bottom. Their melting point goes on increase from top to bottom, and their density also gradually changes from lithium to francium. So the chemical properties will be similar, but there will be a little change or gradual change in the physical properties. Okay, group 18 elements are what? Stable. So this table is arranged in such a way. First group starts from valence 1, that is outer shell contains the electron 1, and the last it ends with valence electron 8. That is valency is 0, but outer shell contains how many electrons? 8. Isn't it? So from left to right, if we see, means it starts with 1 and ends with 8. A group wise, if we see, means all they possess what? Same chemical properties. In such a way, who mostly classified the elements. Okay, I hope that you understood. This topic already you studied in grade 9th. Okay, so I hope it is easy for you to understood. I have attached a worksheet with this video. Only objective type question I have given from the portion I covered today. So you found the answers. Okay, by reading you have to find the answer for these questions. Okay, and here one important 2-mark question is there. It is on page number 107. Modern periodic table, under the heading modern periodic table. What is modern periodic table? It is highlighted here with the black letters. You mark that. Okay, ma? So this is one of the important 2-mark. Remaining you learned for objective type questions. So next class we will study about the periodic trends. Okay, periodic trends in properties. Thank you.